So in this video, I'm going to go through graphing y equals 7/2 or 3.5 sine of what you see here. The argument is 2 times quantity x plus pi over 3. Now what I'm going to do is try to streamline this a little bit, because what I'm going to do is go through one wave. You have to start there. And then go ahead and extend that wave forward to the right one, and then extend it backward to the left one. So essentially you're going to add the period and subtract the period and draw the wave. But I'm also going to find the quarter points, which again, I've done a lot of that arithmetic for you to kind of streamline it. So this is a bit somewhat done, and then somewhat it's going to be interactive. So let's go ahead and start with the one wave. So I think we may have some help from my cat. They love helping me. How about that? They love math. All right, so you have here y equals 7/2 sine of 2 quantity x plus pi over 3. I went ahead and distributed the 2, so 2x and then 2 times pi over 3. Notice your k is 0, and so here are your coefficients. Now I went ahead and set what's in the argument equal to 0 and then equal to 2 pi to solve for the beginning and the end of the one wave, the first wave I have to start with. So I went and did the algebra. My wave would begin at negative pi over 3 and end at 2 pi over 3. So the difference between the end minus the beginning is going to be my period. So there you have it. And be careful with this double negative, right? It ends up being adding it. And then you have your period of pi, which you could also get by using your basic formula, 2 pi over b, where b is 2. So you also get pi, and that's a double check. When you're doing so much of this arithmetic with fractions and stuff, that's a good thing to do. So it may seem redundant, but actually it's checking you. All right, now the phase shift, which is negative c over b, is the same thing as the beginning of our wave. So here it is. Here's negative of c, right? Here's c, here's b. So negative c divided by b, simplified, is negative pi over 3, which is what we got over here. So we're good to go. We know that we have to have a wave, and it's a sine wave, so it starts at the axis, from negative pi over 3 to 2 pi over 3, right? Now, since the period is pi, and I'm interested in finding the quarter points, well, I call them the quarter points, it's because you're going to find, your max and your min and your zeros. I want to find 1/4 of pi. So I want to basically say from, your beginning to your end, I want to basically divide into fourths and find that. So my quarter points, each fourth, is going to occur at a fourth of the period, or a fourth of pi, which is pi over 4. So essentially, if I start at the beginning at negative c over b, and then I add pi over 4, I get my first quarter point, which is my first max coming from the axis. Then I add another pi over 4, I get the second part here where I'm coming down from the max to the axis. Then I add another pi over 4, that gives me the part here, third part here, where I'm coming from the axis to the min. And then I add another pi over 4, and I get from the min to the axis, all right? So here's your calculations. Now, let me just make a couple of points here. So I begin at negative pi over 3, the beginning of the wave, and we talked about what's a quarter of the period. It's pi over 4. So I'm adding pi over 4. That's why I show you that over here. And now I've got to get common denominators. And notice the common denominators in twelfths. So what happens is that period that I'm at, that quarter of a period that I'm adding, the pi over 4, is in a better form here for my arithmetic at 3 pi over 12. All right? So my first quarter point right here is negative pi over 12. So then I come back and I capture that, start from that, and add another pi over 4. But really, I'm just showing you once here. I want to add 3 pi over 12. That's the correct form for common denominators. So I get to 2 pi over 12. I show you the simplification, but honestly, I want to work with 2 pi over 12, because when I come down here and I add another pi over 4, which is really 3 pi over 12, I want to keep it in twelfths, just to make the arithmetic easier. I can always simplify at the end. So that's what I do. All right, and then when I finally get to my last quarter point, where I'm adding a pi over 4 from here to here, I should get the end of my wave, which, let's see, yes, here is the end of my wave, 2 pi over 3, and there it is, 2 pi over 3. So that's another check. It's like, yes, I did that right. Yay. With all these arithmetic calculations, you really get happy when you get it right. All right, so let's take a look then. Let's go ahead and now do the interactive part, where I actually draw just this one wave right here and fill in what we know. So what I would do is I would say, all right, let's just say here's y And let's say here's x axis, right? Now, I begin at negative pi over 3, and I'm going to end at about 2 pi over 3. So I'm just going to kind of guess here. Let's say this is negative pi over 3, and that's about a third of what I'm talking about, right? Because this is ending at 2 pi over 3. So I'm just kind of guesstimate here. It's like, so there's 2 pi over 3. Now I want to divide this into fourths, right? Fourths, because every fourth of the way something is happening. But I know my second fourth is a little bit left because it's negative, right? It's negative pi over 12. It's a little bit left of the y-axis. So I'm probably going to be a little careful here. Let's see. This is probably halfway. Hopefully this is about like that, and then something like that. So if I had great graph paper, this would look better. But there's my fourths, and then essentially what I'm saying, and let me go ahead and do, let me put in 3.5 because that's my, right? 7 halves is 3.5. That's my amplitude. So I'm going to go here to 3.5, and let's say here to negative 3.5, right? And now I'm going to draw my wave where this is my basic shape, right? I start at the axis, go up to the max, come back to the axis, go to the min, go back to the axis, right? So I start that way. That's my basic shape. So I'm going to start here. Okay. Then I'm going to go at 1/12 here. It's almost at the axis, but it's touching the y-axis, but it's not. Then I got to come here, and I'm going to go to the min, and then I'm going to come back here, right? So my first wave then looks like this. Okay, like this. Like that. So that's 2 pi over 3. All right. And then if I were to go ahead and just add these quarter point values in, right, I'd have negative pi over 12. And here's where I'd probably simplify it. Pi over 6 here. And then 5 pi over 12. And then the last one is 8 pi over 12 or 2 pi over 3, which we have. And so now if you were asked to label the quarter points, I would say here negative pi over 3, 0. And then over here I'd be at negative pi over 12, up 3.5, right? Here I'd be at pi over 6, back to 0. And over here I'd be at 5 pi over 12, negative 3.5. And I'd be here at 2 pi over 3 and back to 0. Okay? So that's my first wave. It's sort of it's the basis of everything, because now that I've got this and I know the period is pi, when I subtract the distance between 2 pi over 3 and negative pi over 3, right? So in a sense you have a positive distance and a negative distance, but they're distances, so you want them all to count. So you have a third this way and 2/3 that way to create one whole pi, right? Now, what I want to do next is go ahead and extend this. This is like a little rubber stamp now. I can stamp, 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 stamp in either direction. So I want to go ahead and extend the wave forward, this same wave forward this way to the right, and then backward this way to the left. So let's take a look at that. So here, when I extend one wave forward, essentially what I'm saying is I start at the end of the wave, in this case that's 2 pi over 3, and I go this way to the right, so I want to add pi, which is the period, right? So I want to take the end of the wave and then the period. In our case, the period was pi. Let's see if I have that. Yep. So remember, the period was pi either by n minus beginning or by your formula 2 pi over b, but the period was pi. So that's what I'm going to add. So I'm adding to the end of the wave my period, which is 2 pi over 3 plus now 3 pi over 3 is 5 pi over 3. So this is going to means I'm going to have a wave from 2 pi over 3 to 5 pi over 3. So again, if I want to find the quarter points, I start at the end of the first wave and then keep adding a quarter of the period, or 1/4 pi. But remember, the better form is in 12ths because of the common denominator. So I have 8 pi over 12 plus 3 pi over 12 is 11 pi over 12. And then I just keep adding 3 pi over 12, 3 pi over 12, 3 pi over 12, because it's the same thing as a 4th pi. So here's your other values for quarter point. Okay. So when let's see, did I have that? So forward then, when I take these values that I calculated, this is what I'd get. All right, now here I simplified. So again, if I want to put this together now I've kind of started this. I had my initial one wave. Let me show you that again. From negative pi over 3 to 2 pi over 3. So from negative pi over 3 to 2 pi over 3. But now I have one from 2 pi over 3 to 5 pi over 3. 2 pi over 3 plus the period to get me 5 pi over 3. So this is what I have. And if I wanted to draw this wave, at least 2 waves of this, I would start here. All right. Then I'd go to the max. Go back to the 0, come to the min, go back to 0. Then at the next quarter, go up to the max, come back to the 0, go to the min, go back to the 0. So my wave would be, let's see, let me go ahead and use red. All right. Again, if I had graph paper, this would look, of course, so much nicer, but it's just so much easier to write with Sharpies and stuff for you guys to see. Okay. So there's 2 waves, and again, you can label them. You have all your values, just like I did on my first wave. I labeled the points. You could do the same thing and just continue them, because now you know, excuse me, where each of these values are. This is 2 pi over 3. This is 11 pi over 12. Let me write that down. 11 pi over 12, 7 pi over 6, 17 pi over 12, and finally 5 pi over 3. And you can label all the points. So that's going forward one wave. Now I want to go backward one wave. If I'm going to go backward, I want to start from here, the beginning of my wave, and go to the left or subtract a period. All right? So that's starting from my one wave. I want to go that way, to the left, 1 period. And we said 1 period was pi, right? A period is pi, either by beginning, n minus beginning or period. So we're going to do the same thing, but we're going to do it going backward to the left. So we're subtracting. So let's see, I'm going to extend backwards. So I start at the beginning of my first wave. This is my one wave, the first one that I had, right? Excuse me. So negative pi over 3, and go that way. So I'm going to subtract pi, the period. And when I do my calculations, I get that I will have the beginning of the backward wave be at negative 4 pi over 3. But in a sense, because I'm going backwards, right, essentially what I'm doing is I'm starting here at negative pi over 3, and I'm going to go this way, right? 2, 3, 4. And each time I'm going to go minus pi over 4, minus pi over 4, minus pi over 4, minus pi over 4. So sorry, until I end at this, negative 4 pi over 3, right? Which, because I'm looking at it backwards and we're subtracting, it's really the beginning of the extended wave going backward one, okay? So that's what I'm doing there. So then, here are your quarter points. I start here at negative pi over 3, which is the beginning of my first wave, but I'm going backwards, so I'm subtracting quarter of the period. And these are your quarter point values, right? What I call that. So that means here's what you would end up getting. So this right here, right? Where you're going back 1/4 of the wave. All right. So now, if you want to put all 3 waves together, let's see here, what you would get. So remember, we had done 2 waves. Now I want to do 3 waves. So what I did is I started setting it up a little bit. And let me go ahead and at least label this, what it is we're actually doing. Because this is so long. So we have y equals 7/2 sine 2 times x plus pi over 3, right? And so now what I've done is I've made 3 waves, right? And we knew that the first wave actually was started a little left to the axis, so I did that. And even the second point, the first quarter point from that is just a little bit close to the y-axis, but to the left of it. Now let me show you how I would put it all together. So I would, of course, since my basic sine wave is in fourths, I'm going to divide this into fourths, kind of visually, right? All right. Same thing here. I'm going to go, again, that's probably just a little bit off. Actually, it should probably be more like here. Okay, let's fix that. Okay, and then here, half, and then half of half kind of thing, right? And now the idea is when I graph this, I start here, right? Sine starts at the axis, then it goes up to the max, comes back to the 0, goes to the min, goes back to the axis, goes to the max, comes back to the 0, the min, back to the axis, goes to, oops, sorry, max, 0, min, and here. So here's your, there you go. All right. Oop, this is not so easy. All right, here you go. Okay, and now your values are the ones we've already calculated. This is negative 4 pi over 3, negative 17 pi over 12, negative 10 pi over 12, and actually, let me make this negative 16 pi over 12, only so you could see that the way you hop from one to the other, let's see here, you're going to be adding the negative pi over 4, which is 3 pi over 12, right? So you're going to have 10 pi over 12, and then what? Negative 7 pi over 12, and then negative 4 pi over 12, and then this is negative pi over 12. This is negative 2 pi over 12, no, positive finding, 2 pi over 12, 5 pi over 12, and then 8 pi over 12. I'm sorry, this is actually 20, isn't it? I'm so sorry. I'm going backwards. So for every time I go, is that right? 3 pi over 12, that can't be right. Hold on one second. Let me go back to my points here. We had negative pi over 3 was here. Then negative 7 pi over 12, negative 10 pi over 12, negative 13 pi over 12. Ah, I knew there was something that wasn't right. Sorry about that. This is negative 13 pi over 12. So I'm going backwards every time. I'm going to go negative pi over 4. So going this way, negative pi over 4, right? And then if I go forward, I'm going to add positive pi over 4 for my quarter points. So this would be now 16 pi over 12, yes. All right, my apologies there. All right, so then adding another 3 pi over 12, I get 11 pi over 12. Adding another 3, 14 pi over 12. Adding another 3, 17 pi over 12. Adding another 3, 20 pi over 12, right? And of course, you could always just reduce these like I did this one, right? You could reduce them to make them look pretty, but now you've got it all, right? Where we had all these quarter points, we figured out for the first one, right? Then we went for the going forward, right? And then going backward here. So again, first wave, going forward, you can pause it. Going backward, you can pause it. And each time, right, the difference is this quarter of a period, right? So hopefully, let me put it back to the main wave. Hopefully this makes sense. It's just a lot of work, arithmetic work. Thanks so much for listening.